Hey guys, in this video we're going to be taking a look at dilations and how they can create similar shapes. So the first word we start off with is dilation. And a dilation is a transformation, which is basically a word for a change that follows a set of rules. So it's a transformation, and the specific change that we're looking at happening is a stretch or a shrink. So a transformation that stretches or shrinks the original figure so that it is the same shape as the original, but a different size. The dilations that we're going to do in this class are going to be centered about the origin. I'm also going to tell you that all the angles will have the same measure. And there's some vocabulary words that we could use. You'll often see the original figure referred to as the pre-image. And then the new one is called the image. So the old one is the pre-image, and the new one is the image. And when you're looking at a dilation, it's just basically taking one shape and making it either bigger or smaller, but having the same exact angle measures. So, and again, this would be the pre-image, and this would be the image. And the way they tell the difference, like if this one was named ABC, this one would be called A prime, that one would be called B prime, and this one would be C prime, and it's read C prime. The thing that makes it, there's a number that tells people whether it's going to be a stretch or a shrink, and that's a scale factor. And the letter that they use to represent scale factor is K. It's kind of the same idea with slope as M. Scale factor is represented by the letter K. And it's the amount that the figure is stretched or shrunk, and it's multiplied to the original point. And whenever I'm talking about the original point, I mean the original XY point on the graph. To make the new point, or found by dividing the length of the dilated side over the original side. So pretty much that means new over old. So if you're given any point like XY, and they want you to dilate it based on a scale factor of K, you're going to take that XY and multiply it, so you'll do K times X and then K times Y. So for example, if we had the point 2, -7, and they want us to dilate it on a scale factor of 2, you would do K is 2 times X is 2, and then 2 is our K, times -7 is our Y. So 2 times 2 is 4, comma, -14 is our new point. So if this point was named A, this point would be named A prime. And instead of calling them stretched and shrunk all the time, they have math words to refer to those two. And the first one is a reduction. And the reduction is just the word for when it gets smaller or when it shrinks. And the scale factor, so your K value, is going to be between 0 and 1. So typically people like to say it's either a fraction or a decimal, but you've got to make sure and double check that that fraction or decimal value is actually between 0 and 1. So K is equal to 0.37 would be a reduction. K is equal to 7/8 is a reduction. Both of these values are less than 1. And then the word for being stretched or getting bigger is an enlargement. It's a transformation where the original figure, so remember original figure is the pre-image, and we'll put it up here too, is stretched. So when you do that, the scale factor is going to be bigger than 1. So K value would be 1.23, or K value would be 8/3. So while these are still decimals and fractions, if you look at their value as a decimal or a fraction, whichever way you look at it, is going to be bigger than 1, so that makes them be an enlargement. You can also just have whole numbers too. So if we're looking at a picture of what it looks like, if we have this triangle right here, and we're looking at a reduction, it's going to get smaller, but again, the angle measures are going to stay exactly the same. And if we're looking at an enlargement, the picture's going to get bigger. So if we start trying out some problems, what that looks like. They give us a shape in the coordinate plane. They give us a triangle to start with. It says write the coordinates of the vertices. So the vertices we have R, Q, and S after a dilation with a scale factor of 1/3 centered at the origin. So they tell us the scale factor, so K is equal to 1/3. So if we use the rule that I gave you for scale factor for getting new points, we're going to take the original point that they give us, we're going to multiply it times the scale factor to give us our new point. And for this one, they want us to multiply by 1/3. So here, I'm going to do my math over here. I said xy is our original point, and we're going to do k times x, and then k times y. In this case, k is 1/3 times 9, and then 1/3 times -6. 1/3 times 9 is going to give us 3, and then 1/3 times -6 is going to give us -2. So we just do that again for the next point. 1/3 times 9, and then 1/3 times 9. 1/3 of 9 is going to be 3, and do the same thing again, 3. And then for the last one, we do 1/3 times -9 and 1/3 times -3. And 1/3 times -9 is going to be -3. And then 1/3 times -3 is going to be -1. So this is going to be the answer for what the new coordinates are going to be, given the scale factor of 1/3. Now I know it doesn't ask, but it's good practice. Is this going to be a reduction or an enlargement? And if you look back, the scale factor is going to either be between 0 and 1 or greater than 1. And it says k is greater than 1, or k is equal to 1/3, so that falls there. So this is a reduction. And if you think about this, it's a good way to kind of check and make sure at least you're in the ballpark of what your point should be. If you look at these values right here, compared to the new ones we found, these are smaller than those. And that makes sense because we had a reduction. We had a value that was less than 1. Alrighty, looking at the next one, it says write the coordinates of the vertices after a dilation with a scale factor of 5 centered at the origin. So scale factor is 5. That tells us our k is equal to 5, and they want us to write the new points. So to write the new points, we're going to take our original points, x, y, and we're going to multiply the x value times k and the y value times k. So if we do that, we're going to have 5 times 1, and then 5 times -2. So 5 times 1 is going to give us 5. 5 times -2 is going to give us -10. And then 5 times 2, 5 times -1, which is going to give us 10, -5. 5 times 1, 5 times 0, which is going to give us 5, 0. And then 5 times -1, and 5 times -1, which is going to give us -5, -5. So that's how, if you're given points, that's how you use the scale factor to rate the new points. You could be also given pictures where they give you a picture and they want you to graph the image of the picture after a dilation with a given scale factor. So in order to be able to do this, you've got to pull your points off of the graph. So I'm going to list all the ones we have. We've got T, U, V, W are the points that we have in the graph. Point T has the coordinates 0, -2. Point U has the coordinates 2, -1. V has the coordinates 0, 2. And W has the coordinates -2, -1. We've got a scale factor of 4. So we're going to take our original point, use our scale factor of 4. Now if we use the rule, we're going to do k times the first value, which is x, and then k times the second value, which is y. So we're going to have 4 times 0, and then 4 times -2, and then 4 times 2, and 4 times -1, 4 times 0, and 4 times 2, and then do 4 times -2, and then 4 times -1. And this will give us our new point. So 4 times 0 is going to be 4, -8. This one's going to be 8, -4. This one's going to be 0, 8. And this one's going to be -8, -4. And so if we're going to put the names with it too. This one's going to be T prime, this one's going to be U prime, V prime, and W prime. So there's our new points. But we're not done because it wants us to graph the image. Before I do that, I want to double check. Scale factor of 4. If we look at our rules, our k value is going to be greater than 1. So that means that this is going to be an enlargement. So if we look at our points, the points definitely did get bigger, so we're in the ballpark, we're at least in the ballpark of getting the questions right for the coordinates. Now we just need to graph. So 4, -8. Oh, this should be 0. So then 0, -8. Here's our T prime. And then 8, -4. There's our U prime. And then V is 0, 8. So there's our V prime. And then we've got -8, -4. So there's our W prime. And just like I told you earlier, whenever you're graphing these images, these new pictures, the angles between your new shape or your image and your old shape or your pre-image, the angle measures should all be the same. So if you look, this angle measure should be the same as that one, this one should be the same as that one should be the same as that one, and that one should be the same as that one. And if they're not, that's a good hint for you that you're not picking the right point. And that's actually how I knew that this point right here wasn't going to be right, because for T to be all the way over here, that would make this angle bigger, this angle smaller, and then this angle would be different too, and it wouldn't match up exactly. So that's a good way to double check and make sure that you are getting the right coordinates for your points. And we thought it was an enlargement, and this picture is definitely bigger than our pre-image, so we're at least in the ballpark of getting it right. Trying another one like this. It says graph the image of the trapezoid after a dilation with a scale factor of 1/4, centered about the origin. And all the problems that we do in this class are going to be centered about the origin. If it's not, it would take a whole different new set of rules for us to be able to do the dilation. So scale factor is going to be 1/4. So looking at the points we have B, C, D, and E. B is going to have the coordinates -0, -8. C is going to have the coordinates 8, negative 8. D is going to have the coordinates 8, 8. And then E is going to have the coordinates negative 8, 8. So if we use our scale factor rule, we're going to take our original point, multiply the first value times k, and then the y value times k. So if we do that, we're going to have 1/4 times 0, and then 1/4 times negative 8, and then 1/4 times 8, and 1/4 times negative 8, 1/4 times 8, and 1/4 times 8, and then 1/4 times negative 8, and then 1/4 times 8. And if we multiply those together, we're end up with 0, comma, negative 2. 1/4 times 8 is going to be 2, and this one's going to be negative 2. 1/4 times 8 is going to be 2, 2, and then negative 2, 2. So to name these points, this one's going to be B prime, C prime, D prime, and E prime. So if it was asking for our coordinates, those would be our coordinates and we would be done. But it wants us to graph it. So looking at this, it says a scale factor of 1/4. So going back to those rules, it's between 0 and 1, so this is a reduction. So that means that our image that we get, these points right here, should be smaller than our pre-image. And if we look in general, those numbers are smaller than the numbers that we started with. So we at least have a chance of getting this one right. So if we start graphing, B prime is going to be 0, negative 2. So this one's going to be B prime. And then C prime is going to be 2, negative 2. And then D prime is going to be 2, 2. And then E prime is going to be negative 2, 2. And again, while I'm graphing this, I'm looking to check and see, are the angles looking the exact same? If this line between B and C is a horizontal line, the line between B and C, when you do either an enlargement or a reduction, should be exactly the same. Same thing with vertical lines. If DC is vertical, DC has to be vertical in your image. So there you go. There's how, given points or given a graph, you can do the points for an enlargement and reduction and the graph for enlargement and reduction. The next type of problem that you could have is they could give you pictures and ask you what is the scale factor based on what you see. And there's a couple of different ways you could do the scale factor. You could write down the points and then see what the original point is and see what the value is between them, or you can compare the sides. Either way work. But the first thing you got to do whenever you start is it says you got to figure out which one is your new and which one's your old, because our K value is new over old. So it says the inside shape is a dilation of the outside shape. So that tells me that this one's the new one and this one's our old one. So this one's old, or we could call it our pre-image. And this one is our new, or our image. So I'm going to do comparing the sides. And since I know it's a dilation, I know that they're similar and we only have to compare one. If it was asking if they were similar, we would have to check all four, and we'll talk about that in another lesson. But looking at this one, is the inside shape a dilation? So we're doing new over old. So we count the side. And if I'm basically finding the length from this point to this point. And I'm picking this side to do because it's a nice horizontal side and it's the shortest side in the picture. We could have also picked this one, but it was longer, so I'm using this one. And then these, if you're given all diagonals, you can use them. You're just going to need to do the distance formula to find the distance from there to there and then compare that distance to there to there. But I'm looking to find the answer as quickly as possible, because like whenever you're taking tests that are timed, time's really important. So we want to use our time efficiently, and this is going to get us the correct answer quickly. So 1, 2, 3, 4. So that length is going to be 4. So our K is going to be equal to 4 over, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That length is going to be 10. But whenever you get answers, you always have to make sure they're simplified, and 4 over 10 will simplify to 2/5. So our K value, or our scale factor for this one, is going to be 2/5. And it asks, is it a reduction or an enlargement? Well, if this is our old one and this is our new one, it's getting smaller, so it's a reduction. And if we double check it with our scale factor is correct, because the 2/5 is between 0 and 1. And whenever you pick sides to compare, you've got to pick the same exact. So if you pick the top one here, you've got to pick the top one and the other one. You can't mix and match in between. So looking at the next type, for these it tells us that the outside shape is a dilation of the inside shape. Is it a reduction or an enlargement? And what is the scale factor of the dilation? So if we look, there's reduction or enlargement. Well, we've got to decide which one's the new one and old one. So the outside shape is the dilation, so that means the outside is the new one. So this one's the new one, or our image, and this one's our old one, or our pre-image. So going from bigger to smaller, that's going to be an enlargement. Okay, so to find our scale factor, we've got to do the length of a side of a new over an old. So if we do that, let's go this one right here. So if we pick this one to do, we've got to do that one right there. So this length is 1, 2, 3, 4. So this one's the old, so it's going to be in the denominator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10/4. Need to simplify. 10/4 will simplify down to 5/2. And 5/2 is greater than 1, so it follows the rules for an enlargement, so we're at least in the ballpark. Looking at the last one, this one says the outside shape is a dilation, so this one's our new one, or our image. And this one's our old one, or the pre-image. So if this is where we start and that's where we end up, this one's also going to be an enlargement. And it wants the scale factor, so again we're doing new over old. Let's pick this side right there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So K is going to be equal to 9 over 1, 2, 3. And 9 over 3 will simplify to 3. And the K is bigger than 1, so that follows our rule for an enlargement. So this covers a couple examples of how you find the scale factor given a picture, and then how you can find the new points, given points, or having to find the points, and then using those points to graph. If you have any questions, write them down and ask when you get to class.